Python machine learning, and for this video we'll be discussing about decision tree. So again, my source for this lecture is W3 Schools. So this is how a decision tree looks like. Okay, so I will be explaining more of this later. Now in this video, we'll show you how to make a decision tree. A decision tree is a flowchart and can help you make decisions based on previous experience. In the example, a person will try to decide if he or she should go to a comedy show or not. Luckily, our example person has registered every time there was a comedy show in town and registered some information about the comedian, and also registered if she went or not. Let's say, for example, if the age of the comedian is 36 and experience is 10 and the rank is 9 and nationality is UK, the person did not go to the show. And age is 42, experience is 12, rank is 4, and nationality is USA. Also, the person did not go to the show. And here in this example, the age is 43, experience is 21, rank is 8, and nationality is USA. Then it's a yes. That means the person went to the comedy show. So based on this data set, Python can create a decision tree that can be used to decide if any new shows are worth attending to. So based on this data. So how does it work? So first is we're going to read the data set with pandas. So we have to import pandas, and then we have here the data frame equals pandas that read CSV. So this is our variable, then data CSV. So if we print df, we have this data. To make a decision tree, all data has to be numerical. So we have to convert the non-numerical columns nationality and go into numerical values. Now pandas has a map method that takes a dictionary with information on how to convert the values. So let's say here we have UK 0, USA 1, and others 2. Okay, so means convert the value UK to 0, USA to 1, and N to 2. So example, change the string values into numerical values. So import pandas df equals pandas that read CSV data CSV. Then we have here our set, our dictionary to convert our nationalities. So UK 0, USA 1, and 2. So df nationality is equal to df nationality. So the same, but we've now mapped this one. So that map D using this dictionary. And then the same, yes equals 1, no equals 0. So df go equals df go that map D. So we print our new df, our data frame. Notice here now that our nationality and go are now changed to numerical values. Now then we have to separate the feature columns from the target column. The feature columns are the columns that we try to predict from. So these are the variables that we're considering. And the target column is the column with the value we try to predict. So that's we have the decision to go or not. So X here, the uppercase X, is the features column, and Y is the target column. Excuse me. So again, we have here, we read the data. So import pandas, we read our data set or a CSV file with the data frame, and then we now map. And then we have now features. So we have age, experience, rank, and nationality. So X equals df features. So X here now contains the feature columns, and Y equals df go. So Y contains the target column. So if you print X, so this will be the result. These are the feature columns. And if you print Y, this will be the result, the target column. Now here this will just demonstrate how to display the decision tree. Okay, so we have here the code. and this will be explained. Will it be explained later? No, there is only the result. So we just import this so that the compiler will be able to draw. Actually, no need to do this one if you're using your own, because this was taken from W3 school, so this is needed to display, I think, this tree in the browser. So we have this one, we read the data file, so the same, and we just added this. So D3 equals decision tree classifier, D3 equals D3.fit x, y. And then since we imported matplotlib, so 3.plot3 D3 feature names equals features. So we plot the tree, and then plt.save figure system.standout buffer or standard output buffer, then system.standard output.flash. So we need these two lines to display, I think, from the W3 school. Maybe you can eliminate these two lines, and this will now display the tree. Now you will see the decision tree gives you different results if you run it enough number of times, even if you feed it with the same data. That is because the decision tree does not give us 100% certain answers, so take note of that. It is based on probability of an outcome, and the answer will vary. So now let's try to explain the result with the tree. The decision tree uses your earlier decisions to calculate the odds for you two wanting to go see a comedian or not. Let us read the different aspects of the decision tree. So we have the rank, the Gini, samples, and value. Okay, the rank here, so lesser or equal to 6.5, means that every comedian with a rank of 6.5 or lower will follow the true value arrow to the left, and the rest will follow the false arrow to the right. Okay, so Gini 0.497 refers to the quality of the split and is always a number between 0.0 to 0.5. 0.0 would mean all the samples got the same result, and 0.5 would mean that the split is done exactly in the middle. So 0.497 here means it's almost split. That's why you notice here we have 6 and 7 almost equal. Sample equals 13 means that there are 13 comedians left at this point in the decision, which is all of them since this is the first step. And value 6 and 7 means that of these 13 comedians, 6 will get a no, the first one, and 7 will get a go. To the Gini, there are many ways to split the samples. We use the Gini method in this tutorial. The Gini method uses the formula Gini equals 1 minus x divided by n squared minus quantity y divided by n squared. So where x is the number of positive answers and is the number of samples, so 13, and y is the number of negative samples. So which gives us this calculation, 1 minus 7 divided by 13 squared minus 6 divided by 13 squared. So that's equal to 0.497, this one. So the next step here contains two boxes. One box for the comedians with rank of 6.5 or lower, so this one. And the other box is the one with higher than 6.5. So that's how we splitted this. So that means that what was used, the criteria first used was the rank. So through 5 comedians end here, the Gini is 0.0, so it ends here. You notice 5 will get a no, and so 0 means get the same results, or the same result means that there are 5 comedians left in this branch, so 5 comedians with rank 6.5 or lower, and the value 5 means that 5 will get a no and 0 will get a go. And for the false one, 8 comedians continue. Nationality, so nationality is lesser than 0.5, means that the comedians with the nationality value of less than 0.5 will follow the arrow to the left, which means everyone from UK, and the rest will follow arrow to the right. Gini equals 0.219 means that about 22% of the samples would go in one direction. Samples equals 8 means that there are 8 comedians left in this branch. And value 17 means that of these 8 comedians, 1 will get a no and 7 will get a go. So that's how we view this one. Take note the nationality is what? 0 for UK, USA 1 and others. Then here, so nationality, we have now the next step. So this is based on nationality, and now based on age. So true for comedians continue. Age is lesser or equal to 35.5 means that the comedians at the age of 35.5 or younger will follow arrow to the left, and the rest will follow arrow to the right. Gini equals 0.375 means that 37.5% of the samples would go in one direction. Sample equals 4 means that there are 4 comedians left in this branch. So 4 comedians from UK. And value 13 means that of these 4 comedians, 1 will get a no and 3 will get a go. And the false one, so false here, Gini equals 0.0 means all samples get the same result. Sample equals 4 means that there are 4 comedians left in this branch and 4 comedians not from UK. And value 04 means that of these 4 comedians, 0 will get a no and 4 will get a go. And then so we continue with the next one. So true, Gini equals 0.0, so means all samples get the same result. Samples equals 2 means that there are 2 comedians left in this branch, and value 02 means that 2 comedians will get a no and 2 will get a go. So this is for age lesser than 35. And here for experience now, 9.5 means that comedians with 9.5 experience or less will follow the arrows to the left and the rest will follow arrows to the right. Gini equals 0.5 means that 50% of the samples would go in one direction. That's why you notice we have 1 and 1. Sample equals 2 means that there are 2 comedians left in this branch. And value 1 means that of these 2 comedians, 1 will get a no and 1 will get a go. And then so we have here now the next step. So this was the previous one. So true means all samples got the same result, and means that there is one comedian left in this branch. So that's lesser than 9.5 experience. And means that 0 will get a no and 1 will get a go. And here comedian ends here. So here on the false, true or false value means that all samples got the same result, means that there is 1 comedian left in this branch with more than 9.5 years, and of this means that 1 will get a no and 0 will get a go. So that means you will not choose somebody with higher experience. So now if we have, that's just our basis, but in machine learning we have to predict values. So the decision tree is just used for us to view the tree, but in most cases we just try to determine if it is a go or a no based on the values of the features. So should it go, show starring a 40-year-old American comedian with 10 years experience and a comedy ranking of 7. So the same, we import the following, we map features, then we fit, then we now try to predict. So 40 is the age, experience is 10, rank is 7, and nationality is USA. And then so based on this will give us the result of the prediction. So the result is actually 1. That means it's a go. And here, if it is 0, it means no. So, but this is the result. So that means if the comedian is a 40-year-old American with 10-year experience and a ranking of 7, that means the probability is that the person will go to the show. Now, what if the rank is 6, a lower rank? So import panda, so the same. So 40, 10, this time we use 6, the same values except for the rank. And the result here now is a 0. That means it's a no. So this is an example of the use of decision tree in predicting values. So thank you very much for viewing this video.